Okay, let's get started, guys. Hey, everyone, how's everyone doing today? I know I got ditched a little bit last time, but I didn't realize you can have that much fun. How's everyone doing today? Give me one more time. Yeah! Awesome, you guys rock. Welcome to Gaming Track 304. The title of our talk is How We Reinvented Our AWS Model. And this is really just a short story about how we started in the data center, we started moving some things to AWS, a lot of the struggles we had, and how we tackled some of that growth. So let me introduce myself. My name is Marty Chong. I'm a senior network engineer on the infrastructure as a service team. So what that really means is I'm responsible for the design and the vision of our infrastructure and automation, both in the data center as well as the cloud. Now, I've been working for Riot for about 2.5 years. And I'm coming to you today all the way from the misty mountains, from the dark forests, from the lands of bears and Sasquatches, that's also called North Vancouver, British Columbia.
My name is Jonathan McCaffrey. I'm a software architect at Riot. Been with the company for about 6 years and worked on a bunch of different stuff, including our website, some of our platform, and some of our organizational things. Today I'm going to talk about LeagueOfLegends.com.
So quick show of hands. I won't do this to you all day, I promise. How many people have heard of Riot Games? Wow, that is so awesome. And out of those people, how many have played League of Legends at least once this year? Hopefully, when your boss wasn't looking, you didn't have anything to do. So one of our missions is we aspire to be the most player-focused company in the world. We've achieved some really, really incredible growth, and that's really a tribute to our players. And so staying connected to that idea of being player-first is really, really important to us. As I said, we're the developer and publisher of the game League of Legends, which, again, a number of you people have been playing. And one of the things that we've also had success in is our esports and hosting some of the world's largest esports tournaments. So really quickly, for those maybe not quite as familiar, we're going to talk a little bit about League of Legends. So we launched League of Legends in 2009. And League of Legends, again, most of you guys know, but it's a team-oriented game. It's a 5-on-5 game where you get into this battle arena. You join a team of 5 guys. You play against another team of 5 guys. And you pick from a whole bunch of different champs. You could be an archer. You could be a mage. You could be a healer. You could be a trickster, an assassin. And you're pitted against each other. And you're trying to do all these different objectives, but eventually destroy the other team's base. And we're based on that modern fantasy genre. So we have new champs that are being released all the time. Each of them has a different story and a different lore that connects you kind of to that fantasy world. And so no two games you play are really ever the same. And that's one of the things that I've loved about it was, you know, I was able to play League of Legends for many, many years, and it had a really great replay value because we're always coming up with different maps, different champions, and it's always a different experience playing with different players. So here's a few screenshots that you can have a look if you haven't played the game before and you ever see someone playing this next to you. This is a game here. We've got a big team fight here at Baron. Looks like someone's getting smashed. Okay, let's have a little bit of a change of pace. Let's do a little bit of trivia. Who can guess where this photo was taken? Where in the world is Carmen Sandiego? You can just shout it out. Seoul, Korea. Wow, awesome. If I had my t-shirt, we were told no t-shirt cannons, I would fire your t-shirt right now. Awesome. This was hosted at the Sangam Stadium in Korea. So one of the things that was big for us was esports, and we started at DreamHack in Sweden. Last year, we sold out the Staples Center. It was phenomenal. We had 14,000 screaming fans there. We had a full symphonic band with a unique score, and it was really, really one of the highlights that we had last year. This last year, and this was in Korea, like this gentleman mentioned, and we sold this one out. We tripled our numbers. This was 44,000 screaming, really passionate Korean fans. And this was hosted in Sangam Stadium. It hosted the World Cup in 2002. And not only that, we had some of the most amazing, amazing music. We had Imagine Dragons write some original music for us and actually open and close the show. So that's freaking awesome. Imagine freaking Dragons. So every time I look at this, I get a little bit jealous and sad. And I'll tell you a little story. You know, when I was 8 years old, I used to go and I used to kind of tiptoe, and I would go to my parents' basement and I would power on my Commodore 64 as quietly as I possibly could. And I would put in hours and hours and hours and hours of heavy hours just ripping on Frogger and Jumpman, and I got really, really good. But I never had a chance to play on stage in front of Imagine Dragons, so maybe in another life. Okay, so let's quickly look at some stats and talk about scale. 67 million people signing on at least once a month and playing our game. Oops, sorry. 27 million daily active players, and more than 7.5 million players that are online playing our game at any point in time. And so with this type of scale, it's really important that we are able to reach out to all of our players. And one of the ways we do that is through our web services.
Cool. So yeah, today we're going to talk about a few different things. We're going to talk about kind of what League of Legends, which Marty mentioned. We're going to talk about how we started when we moved to AWS. We tackled some of our growth in AWS and some of the things we saw. But LeagueOfLegends.com. So LeagueOfLegends.com is the community hub for all things League of Legends. If you guys are, let's say, an Ashe player, she's your favorite champion, she's an archer, you go to the website, you want to see if she got buffed in the last patch, if she got nerfed. That's the kind of information you want to get on LeagueOfLegends.com. Check out your news, any kind of stats on there. If you're a new player, this is where you're going to go to see guides about the game, other things like that. It's also where you can manage your account, refer your friends, change your password, verify your email, or even interact with our community. So you can go on our forums and you can post and you can see what the kind of the beat of the community is. So this website does a lot of different things. And League of Legends is a global product. So we have League of Legends all around the world. And this is interesting. We run League of Legends in data centers around the world. So a lot of you guys are probably in the cloud for most of your stuff. With this, we're actually in a data center for a lot of things. And we've moved some of our stuff to AWS, and that's what we're going to talk about. If you go on LeagueOfLegends.com and you hit this drop down at the top, you'll see a bunch of different regions for the game. And from a player experience standpoint, these are different websites. And they may be hosted in different places around the world. If you guys come to our booth or we log in today, well, most of us are going to play on our North American region. So if I create an account on North America, that's in a server in a data center sitting here in North America. That's separate from like our servers in Europe or South America, which is a different model than a lot of websites and stuff that you guys may use. So from a technology standpoint, we had a couple different goals with LeagueOfLegends.com. One of those goals is security. We really want to make sure we're preserving the player experience through any kind of malicious attacks or making sure player data is safe. Quality is really important as well. We want to make sure that we're creating a highly available performance site experience that's always on when you want it. And finally, agility. We want to empower our dev teams to own their full value stream to live. So this is come up with their software, build it, ship it, and operate it themselves in live. So let's look at how we did these things initially. Like I said, we started in the data center, and we had a couple struggles. So in our data center, we have kind of an edge stack. And that edge stack has a bunch of security devices and things that kind of help us with the basics of DDoS attacks, things like that. And we had a pretty good perimeter network security inside of our data center. We built a monolithic app. Now, I don't know if any of you guys have done this. You probably didn't because you're good engineers. But we built a monolithic app, and that was one of our fun times. We deployed this on physical servers. So these are servers that we racked and stacked specifically for this application. If we wanted to add another app or change how many servers we had for scale, we're again racking, stacking, doing planning, making purchase orders, stuff like that. So today we're going to talk about a couple different things. We're going to talk about our monolithic app, our physical servers, our network security, and we're going to look at our goals and see how we did. So like I said, LeagueOfLegends.com ran on this app that did a lot of different stuff. We had our front page, our news, our media galleries, we had comments, we had account security. And these things are vastly different. Like, news and front page are content systems. One person changes those at Riot, and everyone sees that change. Comments is a UGC system, right? So users make changes and see them changes themselves. Account management has PII data, and there's a lot of security implications with that. So with all these things baked into the same app, you can imagine some troubles. Let's say a refer friend system goes down because Jonathan McCaffrey wrote a really bad query, which happens a lot. So I put that in there, and refer friend starts to chug. Well, this is the whole site now starts to chug, right? So I come to the site, I'm like, oh, news is slow, everything's slow. And it's hard for me to figure out which thing caused that. So we had a lot of kind of availability struggles, as well as triaging issues were hard when we had a monolithic app. And again, we're on physical servers. So this kind of left me with an interesting choice, right? If I want to build a new feature, I'm sitting there like, I can do the thing I know how to do, right? I can put that change into my monolithic app. I can commit it to Git. My QA team can go through there and test it, and that's great. Or I can try something different. I can go through a long process where I'm going to provision servers, set up a bunch of stuff, come up with new deploy processes, have to train guys on new things, set up new monitoring, and we rarely did that. So when we weighed these two options, most of the time we're like, we'll just put it in the monolith. That's great. And that piled up after a while and became a problem. So we found that our physical servers, and in general, our kind of static topology, made it hard for us to do the thing that we knew was good. If I came to any of you guys and said, what should we do? You'd be like, don't do that. But it was hard for us because we were in this kind of limited model. So we started looking for ways that we could do that better.
One of the biggest things that we struggle with just as being a gaming company is network security. So I think, anyone get hit by any of the application attacks that hit NTP back in the day? I hope so. We got hit by this, and so as a result, one of the things that we needed to do was be able to invest in infrastructure. So from a network security standpoint, we got a lot of things free within the data center. And just quickly looking at this diagram here, you can see we have our routing edge where we're doing our peering. We have our DDoS mitigation where we can go and look at ways to mitigate attacks from a protocol abuse perspective and a volumetrics perspective. And then we have policy enforcement with our firewall. But we're a little bit different in the sense that even though we're talking a little bit about the web here, in the data center, we have a lot of other different protocols. Some are UDP-based, and some are kind of customized to the point where we need to really kind of be able to really dig into the packets and really understand what's the difference between legitimate player data is and an attack. And even the most minuscule impact on our servers can be just catastrophic to our players, especially in really competitive ranked games. So in the data center, we got granular DDoS mitigation, and that was great. And so we knew that if we were thinking about moving to the cloud, we needed to make sure that we had that level of protection. At least we had a level of protection against some of those big volumetric attacks. Firewall, we need to be able to deep dive into our packets, make sure people weren't trying to take advantage, do things like scrape our servers down. And so that was another important thing we needed to be able to offer. And lastly, monitoring. We needed to have really good visibility and auditing into our policies, right? What happens if someone leaves an ACL open? Are we going to be exposed? Are we going to be going and re-imaging servers as a result of a compromise? So it was really important we had that visibility, whether we decided to stay in the data center or move to the cloud. So let's revisit our goals really quickly. So we got a lot of things for free in the data center. We had the anti-DDoS, we had the policy enforcement. But one thing we weren't really using was we weren't really using a CDN. And what the CDN actually did for us was it gave us that really nice front line to absorb some of these volumetric attacks and be able to do things like block or blacklist certain sources. From a quality perspective, everything, as Jonathan said, everything was monolithic. It was all stacked in CMS and forums. And even though the CMS was doing a lot of things, Jonathan was running the maze of the labyrinth and going between finance and purchasing and trying to get stuff rack and stacked. And as a result, it made us make kind of poor decisions in terms of the way we handled our code. And lastly, agility. So this is the static server topology. We're running around. We're trying to do these things. Now we really wanted to be able to enable development teams to be agile and to be able to work on things instead of worrying about when servers were getting deployed. So now we're going to talk a little bit about our struggle to scale. So we decided, you know what? Let's do it. Let's move League of Legends to AWS. And so here, I'm going to take you really quick through the diagram here. So this is a basic diagram. We have our players out there that are sitting on the internet. We have our CDN that we put in front of it, which is excellent. It gave us that front level of protection. Of course, we're going into Elastic Load Balancer. And then here's our community CMS. And for the most part, this is still one stack. We have our front-end servers, and we have our RDS that we're leveraging as a database backend. But what's interesting is that even though we moved into the cloud, we weren't autonomous, right? So, this was something that still depended on services within the data center. And we depended on one of the biggest services was authentication. So Jonathan wants to go in and log into the forums. It talks back to the global authentication system in our data center. And so as a result, we needed to leverage VPN connections from our VPC into the data center. And we chose VPC because we wanted that inherent network security. We didn't want to just go and expose the website and put it on a whole bunch of public elastic IPs. We wanted to have that protection. But one of the cool things was it really enabled us to kind of spin up new microservices. And the tournament CMS is an example of that. We were able to spin up a whole separate stack for esports tournaments. So finally, we've got a microservice. Finally, we're moving away from that monolithic model of just bolting onto the original app. And this was really exciting for us because it got our dev teams owning the entire thing from the conception to the build to the deployment and then owning it live. so really quickly, let's start with our VPC and have a look at this. So this is kind of where we get into a little bit of struggles when we moved to AWS and how we scaled it based on our model. So before, we were still logging to the CMS site, and the CMS was still talking back to the data center to do authentication. And it talked to a few other things, too. There were some code repos. It leveraged a little bit of DNS, a little bit of NTP. We had a little bit of everything back there. And so here's an interesting diagram. We've got all these kind of circles there are sites. So we've got 3 VPCs at the top, and they're arbitrary. They could be US West 1, 2, and US East, for example. And all of the FIST, which is kind of our logo here, is Riot data centers that we're going to talk back to. So Jonathan decides, OK, I'm setting up NACMS. I'm going to go and talk back to authentication service. So we created one VPN connection for that. But with a VPN connection, sometimes, depending upon how you terminate them in the data center, you may have 2 endpoints that you terminate them on. And so really, we had 2 VPNs to manage. OK, that's not too bad. But we're a global app, right? So we have different regions. We have North America, we have Europe regions, we have Turkey, Russia, South America. And so as we started to scale those out, we ended up at kind of 10 VPNs. It's quite a lot of VPNs now. And our big data team came to us one day and said, you know what? You guys are doing this stuff with the cloud. This is really cool. We want microservices too. You know what? Guess what? We want to set up, but you know what? We're going to go ahead and set up in US East. Okay, but they need the same connectivity to the data center. And then we thought, you know what, maybe it's a really good idea and a good practice if we separate our prod from our staging. It might avoid a few problems. And so now all of a sudden, 20 turned into 40. And 40 eventually turned to this, and it became a spider web and a nasty mess of VPNs. And we had issues when there was maintenance going on and some of the stuff that we had problems with route predictability. We had some scaling issues. And it was really tough to be able to enforce our security policy. So the Marty that you see in front of me quickly went to this Marty. And it wasn't a good thing. So even though the VPNs really enabled us to be able to talk between our data centers at launch, we really hadn't thought well enough about how we were going to scale them and how we were going to manage them.
Yeah, and we're still kind of learning here. So as we moved into VPC and AWS, we had a couple challenges like that. Let me talk a little about microservices. You may see a theme there. So when we moved into AWS, it was about the same time we started doing tournaments with League of Legends around the world. We started in Sweden. We did DreamHack. We started doing some World Cyber Game stuff, and we ended up doing a lot of tournaments around the world. Each of these tournaments had their own website, their own brackets, their own stats, their own videos and streams and stuff like that. And this was a really cool opportunity, because now we're in AWS. We can spin up different servers. We can run things differently. So we started to build new software running on new servers separately for tournaments. And that kind of basic idea let us really break down our CMS into a bunch of different things. One example of that is comments, and I'll dig a little bit deeper here. So comments is a Java service that we wrote. It provides a REST interface for accessing what comment data is for a page. And it's talked back to you by a comment widget, which is a JavaScript app that we wrote as well. So when you go to a page like this news article, the comment widget reaches out, grabs those comments, and loads them into that page. Now, comments, again, is a separate service running on separate hardware with a separate code base. And that comment widget is also separate. If comments don't work, it doesn't render that thing. But the news page is still up. The front page is still up. My referred friend query, which is really bad, is still up. And all those things are still working. So comments is able to scale and fail independently due to this architecture, which was really a step forward for us. But as we started to get more and more of these type of things, we went from maybe 2 or 3 services running to maybe 20 or 30. And that made automation a lot more important. I could skate by manually, maybe with a couple services, but with 20 or 30, it's really not possible. So we started taking some pages from the rest of our company, and we used Chef to do our deploys. I'm sure a lot of you guys are doing that as well. So here's what that looked like. I would go into EC2, and I would spin up an instance, and then I would bootstrap that instance into Chef. Those instances would then reach out to the Chef server and download their config and cookbooks and other stuff that we wrote to make themselves work. And finally, we'd have some instances that are good to go. And this was good. This unblocked this. This automation allowed us to kind of get off the ground and do our microservice thing, which was really cool. But it had a couple drawbacks. One of those is that we weren't really using AMIs correctly here, right? Like if I right-clicked on one of these guys and said launch more like this, I'd get blank boxes, which is not what I want. I wasn't able to take advantage of auto-scaling because of that, and that was an issue. Second, this is fragile, right? I'm talking to Chef server, Nexus, I'm talking to maybe Yum repos and a bunch of things. And those things might be in the data center, like Marty mentioned. I might be going across that mesh of VPNs. That's really scary, and that's bad. And that would be for any change, config changes or code deploys. And finally, this is complex, right? When I want to do a deploy, I'm running a lot of different code at once. And maybe I'm running 100 steps for something that may be changing one file. And that's pretty bad. And that made it so that any type of change I wanted to do maybe would cause me to have to crash. And I would do it manually, which defeats the point of having automation. So that was an issue. So if we look back at our goals, we had some things. We implemented the VPC. We got some of our security goals achieved. But we struggled to scale that. From a quality standpoint, we took advantage of the CDN, and we started to separate our services, but there were still a lot of things in that CMS. And finally, we automated our deploys, but that automation was fragile and came with a lot of pain.
Yeah, and one of the things that we kind of had to do is we had to really adapt and be able to tackle our growth. And I mean, how many of you guys here have got to the point with AWS where you guys really grew big and you just said, oh, damn, we have a lot of stuff? Good amount? Yeah, awesome. And how many people walked through the expo hall and got some really, really cool swag and were promised and told that they would solve all of your issues for you? Yeah. and you know what, maybe they will, depending upon the environment you're in. And so we had growing pains. You guys have had growing pains. I think these guys know about growing pains. I'm pretty sure they have, right? So one of the things that really kind of brought us a lot of agility, and we were starting to really do things from the development side. Also, we struggled to scale them in a way because there were a lot of dependencies that we really didn't think about. So we have Miss Fortune here, and she's saying, what brought us that agility also brought us the Wild West of cloud computing. We're going to talk a little bit more about, how that worked out. Talk about scaling the VPC. We're going to talk about the AWS working group. Sorry, you can't really see that one too well. Golded image deploys, static site hosting, and then we're going to kind of wrap up everything. So we had two really, really big pain points when we moved to Amazon. One of those was infrastructure pain, and that's the dependency on some of the existing infrastructure, because we were a hybrid model. Now, how many guys here just live purely in the cloud? They don't have data centers at all? Okay, some of you guys, actually quite a few of you. Okay, so we'll actually talk a little bit about that. Are you guys in the VPC? Or are you guys, okay, you're in VPC, awesome. Or a lot of you guys are. And then the other one, and the other one is organizational pain. And so that's, when you have a number of different teams within your organization, maybe using AWS a little differently, and how that can be a bit of a challenge. So let's first talk about infrastructure pain. And I'm just going to rip through this diagram here. So we have AWS, and then, again, two arbitrary VPC regions. We're talking back to our Riot data centers because we're still a bit of a hybrid model. Now, if you're in the VPC, those could be VPCs in other regions. And then we have our CDN in front of it to offer our security. So you remember this guy here? He wasn't really very happy with kind of what was going on. And so there's a couple different techniques that we were able to use to kind of lessen that pain. So the first one was we really tried to consolidate. And so there's a talk going on right now. I think it's ARC 402. Where they're going to talk about, single VPC design versus multi-VPC design. What regions do you want to be in? Where's your compute going to lie? But for the most part, if you're able to reduce the number of VPCs and the number of accounts you use, you're going to create a lot less infrastructure pain. And that doesn't matter. Even if you're just in the cloud, you need to talk between VPC to VPC. Peering connections will only get you so far. And so that's going to create a lot less work, and you're going to end up redoing a lot of the same connectivity that you need more than once. There we go. So the other one, and this is something we have too. So I've got a multi-point VPN that I'm showing on the right-hand side. But if you're in the data center, for those of you that are in the data center, you might have, your data center is all connected. Maybe they're using MPLS with a service provider. Maybe they're using like a Cisco DMVPN or a Juniper Group VPN. But you've got them connected in some way. And so we talked about this, how do we get this multi-point mesh going? And that can be a little bit difficult. And sometimes we've had compatibility issues even with talking to your VGW. And it can get a little bit trying, if maintenance goes on. So one of the things, you may want to consider is trying to extend your network or your data center into the VPC. And so you might want to use something like an Open VPN, Open Swan, do a custom solution with an AMI. Or now we're seeing a lot more with the bring your own license models with like the Cisco CSR 1000V, the Viata and the Sophos AMI. And that might give you an advantage for integrating into larger sites. And you kind of remove that pain. You put that control back on the instance itself. And Direct Connect, of course, right? The flagship AWS Direct Connect, and that gives you that nice dedicated fiber between your data center, and the Amazon region. It's awesome because it's account agnostic still. So if you guys are trying to consolidate, it'll allow you to do that and give you access to all those different regions. And it also really gives you that always-on performant connectivity that you may be looking for in your organization. Okay, who's this guy? Shaco. Shaco. I think he reminds me. Anyone watched American Horror Story? No? American Horror Story. Twisty the Clown. I think he's Twisty the Clown's older brother. So this is a little bit dark here, but this image of a Shaco, and Shaco is a demon jester, and he's a really kind of tricky guy, and he uses deception and illusion in the game. And one of his skills he uses is he plants a jack-in-the-box. And he plants the jack-in-the-box. He might plant it in the bushes everywhere. And if you are on the other team and you are unfortunate enough to step on that jack-in-the-box, it will jump out at you. It will deal you damage, and you will run away and flee in terror for 2 seconds. And then Shaco will usually appear and stab you in the back and try to kill you. And then your team will yell at you for feeding. But Shaco was a jackster, but the jack-in-the-box. And so we ran into a lot of those, not just with VPNs and stuff, because I know not everyone's necessarily using VPNs, but also with how we set up our VPC, right? And this has been talked about a lot before, and we just want to share a few kind of things that we did and kind of where we stumbled a little bit. So we had all these different groups using it in disparity. And we said, you know what, why don't we look at consolidating things? Let's come up with a shared model. So here on the diagram, I have a VPC here. And what I've done is I've illustrated the subnets in just horizontal bars. Now, you would have, obviously, a bar for each availability zone, but I just tried to keep it simple. So you've got your public subnet, and that's where you're going to have all your elastic load balancers, or most of your elastic load balancers. You're going to have NAT instances. You might have other proxies. You've got a shared tool subnet, and that's something we like to use for things like internal monitoring and things like code proxies. And then all your applications. And so all the applications sit in one. And so this is kind of neat in the sense of kind of easy to admin. Everything's sitting in one place, good visibility, not too many VPNs or not too much infrastructure dependency. But it has some problems with it. One of the problems is it lacks security granularity. How do I whitelist a payment app from not being able to talk to a database? How do I whitelist something from not being able to talk to the data center? Everything sits in the same subnet. It gets auto-assigned an IP. And not only that, there are things that we need to talk about which are hard limits with AWS and VPCs, right? So it's not just a matter of creating a support request and saying, hey, increase this limit, or talking to your account rep. Some of them are hard limits based on the SDN that Amazon runs. So we thought, you know what? We can offer that security if we just kind of split subnets for every team or every application. And that way we can do the whitelisting, we can have granular security, use security groups or network ACLs, and sure, everything's going to be fine. And it's going to be easy on the VPN infrastructure, but we still run into limits with things like security groups. And so we could look at, well, maybe we'll just do a VPC per team or a VPC per initiative and just give everyone their VPC. Well, that's great, but we kind of just kicked that problem down the road of some of the infrastructure pain and being able to manage all these different VPCs. So one of the things that we were looking at, and Jonathan was talking a little bit about automation, and we're really trying to work in automation with, and look at doing things like open source and things. But one of the things we're looking at is commodity-based VPCs. So what if we just threw out that whole model of like a team owning a VPC, and we decided, okay, we understand what our limits are with a VPC, technically. We want to have the security granularity. What if we just had an automation tool that would give us the ability to look at and spin up VPCs as we needed them? And so here you can see we've got 2 VPCs. They would probably have more than 3 apps in them, but just to illustrate. And then the next one gets auto-created as soon as we have an app that needs it, because it won't put it in VPC 2. The other thing that we needed to talk about was organizational pain. And one of the things that we were able to do and able to conquer this was through a working group. And so what we had when we first started Riot is we said, you know what, go to AWS. No restrictions, no constraints. You guys are good. Just go log on, create an account, go ahead, use it, spin up your app. Awesome, right? Unless maybe you're in finance. And then, so we had all these teams, and they were working independently, right? But the thing is that they were doing everything kind of on their own. They were arbitrarily selecting regions. They would set up their VPC differently with a different subnet structure. Some were using tagging, some weren't. Some were using auto-scaling, some weren't. And so we had this real disparity of all these different teams. In some cases, the teams were actually writing tools and not really even sharing that information. So another team would be like, hey, we need to do this, and we were actually duplicating work, which is really, really horrible for an organization. So one day, Jonathan and myself and a number of different other people got together and said, we need to talk about this pain. This is really, kind of getting out of hand. We've got we're coming up on 20 accounts. We've got VPCs everywhere. We've got a real disparity in what we're doing. And so we were able to meet, and we still meet on a regular basis to talk about some of these growth issues. We were able to do some consolidation in a number of accounts. We were able to gain consensus on things like tagging, auto-scaling, create best practices, and we're also able to share tools within our organization that Jonathan's going to talk about in a little bit that really enable us to be able to deliver on our agility. So really quickly, the Marty that was like that turned into a Marty that was very, very stoked. A little bit dark.
Yeah, and that kind of streamlining and coming together and working across the organization is something we try to do with a couple different things. And one of those things was our automation. So like I talked about before, when we started, we took a page from the playbook of some of the other guys in our company, and we used Chef, and that helped us get off the ground. But as we began to use AWS more, we had some anti-patterns with that. So what we're doing now is a little different. Now, when I make a code change to one of those services, let's say it's the comments, I commit that to Git. A Jenkins job fires, and as you guys know, builds a tarball or a jar or a war or some kind of build artifact for my code. Hopefully it runs my tests, which should pass, and then that Jenkins job spits out a good artifact. We then run an open source tool called Packer. And what Packer does is attempt to take that build artifact that we made and create a cloud image out of it. And the way it does that is it spins up an EC2 node, it uploads my tarball or whatever, it runs some scripts that I've written, and then it snapshots it again. So every time I commit to my master repo, I get an AMI that's that version. And I clean up the old ones or the ones we don't use, but the ones we actually run in production I want to keep around. And I get an AMI for every version, right? And what this does is it allows me to go into EC2, I can right-click in the console on that AMI, and I can say launch. And now I have a working copy of my app. All those build steps, all that complexity, all that stuff, we push that all to build time, which really helped us out. So if I want to deploy these, I use auto-scaling to do all the work. Again, I like writing code, but I like Amazon to do most of the work here. So I just set up the auto-scaling groups and say, I want this version of my code, I want this number of servers, blah, 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 and it does it. If I want to deploy a new version, here's what I do. I create another auto-scaling group, configure with my new AMI, right? I use ELB health to tell me when these are looking good, when it's healthy. And when the new version comes up and is healthy, I'll delete the old version out of delete the old auto-scaling group. So this deploy is really just making auto-scaling groups and letting ELB and auto-scaling kind of do the work for us. Let's say I bring that thing up, though, and it never becomes healthy, right? I made some code mistakes. I'm prone to do that. And so I put it up, and it never becomes healthy. Well, if it doesn't become healthy in ELB, we don't send it any traffic. If we don't send it any traffic, there's no player impact. And so we can just delete it when we roll back, no problem. But more commonly, I'll push that thing out. It'll become healthy. It'll pass my tests. But maybe I messed something up really bad on the home page. CEO calls me and is like, bro, get that off. So I'm like, OK, let me roll back. So I'm going to put V1 up, create another auto-scaling group. And when V1 looks good, I'll delete V2. And this is simple, right? We're not doing any magic here. And we've allowed a lot of teams at Riot to achieve continuous delivery and continuous deployment with just using auto-scaling groups, creating them, deleting them, and stuff like that. We use the Botto library, which I'm sure a lot of you guys are familiar with, to automate this process. And we created a tool called PackMule, which uses Packer and Botto to make an easy-to-use workflow that does these things I just talked about. And we're looking to open source that in the near future, so if you come to our GitHub Riot Games account, you can follow us there. But that's only for services. And like I talked about before, LeagueOfLegends.com does a lot of stuff statically, right? This page is on LeagueOfLegends.com. If you're a new player, you'll see the new player guide here. That's just a markdown file, right? So when our editors want to change that, they just make an edit to a markdown file. They commit that to Git. A Jenkins job is going to fire on commit again. And it's going to run a tool that we created called Spark. Now, I know there's a lot of tools called Spark, so kill me, right? So we created a tool called Spark. And this is a static site builder. And we have a lot of very specific localization workflows inside of Riot. So we made this simple tool to compile all this stuff into a working static site with all the different languages we need. Spark's also going to upload that site to an S3 bucket with website hosting enabled. And we're not running any servers here, right? So with website hosting enabled, I just upload that, and now I'm the person editing it, and I can see that change immediately. If I want to deploy that production, I just run another Jenkins job which copies it to this production bucket, and now my static site is out to users. And I'm not running a server. I'm not doing a deploy. I'm not doing a bunch of complicated stuff. S3 static website hosting really helped us. With these static sites, in the 2 years we've been running it like this, we've had 0 downtime. And we do a lot of giant promotions on there and things like that. No issues. But it's not perfect. So if we look at our goals, we're using our CD in front of everything, which is really helping us. From a security standpoint, like Marty mentioned, from a performance standpoint, we put it in front of those S3 buckets as well. It really helps us with a lot of things. But we're still struggling to kind of figure out what our model is for the future. From a quality standpoint, we are starting to use full page caching, build our microservices, and using static sites, and that's going pretty well. But we haven't really balanced our AWS regions. A lot of the stuff I talked about is in US West 2, and we have a global player base, so it's nice if we can spread around the world. And finally, we're doing fully automated deploys on small, simple services, but a lot of those things like auto-scaling and stuff is in the cloud. Now, if I want to make it easy for a dev to do that on their local machine, that's something we're exploring, maybe using Docker or other tools like that.
So as we wrap up here, because we want to give you guys some time before the pub crawl and happy hour starts, there's a couple of things you may want to think about, and we thought about a lot when we were able to kind of achieve some of the things we were, and we're still working on some of that stuff. One of those is communicate within your organization. So we formed a working group that really let us gain consensus on stuff, share information, and a lot of that stuff is actually kind of manifested itself in different tools. So one of those things that we did was we had problems with things like managing users, managing user accounts. And we were able to, through communicating with our organization, basically consolidate our entire organization into single sign-on. So we have an intranet that basically you go and sign on to. We enforce two-factor authentication. And then you will get a portal with whatever AWS account you have, and you will log into the console that way. And we're able to enforce very granular IAM permissions, and we're able to consolidate and easily have a single point of truth for where that account lives. So that was one of the things we were able to achieve. Another thing that we were able to achieve was through documentation, and sometimes code is the best way to document. We started sharing code, and we started actually using and leveraging some of the open source community tools that are out there. So some of the Netflix tools that you see now that are being kind of open source, like SecurityMonkey, we started leveraging those within our organization to gain a lot of that visibility, and we're looking at contributing to a lot of those sources. Jonathan also talked about Packmule, and check out our GitHub repo. We're looking at trying to open source some of those tools and share that with the community. Stay tight with your Amazon account team. And so this is one thing I think we, kind of hit us a little bit in the sense of a lot of times, Amazon has a roadmap and they're working on improving different things. A perfect example would be the peering connections, right? So you want to talk from one VPC to another VPC in a different account, same region. And a lot of times if you're not really plugged into what's coming down the pipe, you might miss that. And you might be solving for a problem that Amazon is actually going to solve for down the road. So it's important to stay tight with your account team. And try to figure out and try to squeeze whatever you can out of the roadmap, right? Learn from our mistakes and learn from others. We made a whole bunch of mistakes when we first went into Amazon. We were so excited about this agility, and we were so excited about volumetric protection and features like auto-scaling that, in some of our VPC and our concept designs, and also the way we operate as an organization, we really, made some missteps. So, don't do what we did. And also learn from others too. There's a lot of really, really talented, smart people. I can see all of you right now. And you guys also have a unique perspective on how you've solved problems in your environments, right? So please get out there, talk to people, introduce yourselves, go buy everyone a beer, and let's see how we can make it, better, and see how you can make it better for your organization. And that's it. Thanks very much, guys. My name is Marty Chong.
And I'm Jonathan.
And please visit us in our expo hall.